Welcome to EDU World Space.
All right, so we need to calculate the internal resistance of the battery, the EMF, and the resistance of the resistor. Now, this is the circuit diagram that we have. So first of all, when the switch is open, we know that the voltmeter reading is 3.08 volts. Since switch is open, that means current cannot flow in this loop because the loop is open and it does not have a complete path. So what that means is that current is zero. Good. So we will use the terminal equation for a battery, which is given as the potential measured across a battery is given as the EMF minus the current flowing times the internal resistance. So what this equation is telling us, the potential difference across this region. And this is measured by the voltmeter over here. Since current is zero, this term drops out. So we get our EMF is equal to V, which is just 3.08 volts. So this is the first part of the question. So this is number one. So part two is about calculating the internal resistance of the battery. Now, as soon as the switch is closed, the measured value of the potential is this, and the current measured value is this. Now, current will start flowing in this loop. The direction of current is like this because this is the positive end and this is the negative end, and current flows from the positive end to the negative end. Again, we will use the battery equation or the terminal equation, V equals EMF minus I times R. Here we will substitute the new values of the ammeter and the voltmeter. Why new? Because this is the case when the switch is closed. So we get 2.97 equals EMF, which we already measured, minus the current, which is 1.65 times R. Rearranging things, we get R equals 3.08 minus 2.97 divided by 1.65, which tells me that R equals 0.066 ohms. Good. We have measured our internal resistance as well. Good. So we have our EMF and we have our internal resistance. What remains to be calculated is the resistance of the resistor, which is the capital R. Okay, to calculate it, we will use Ohm's law. Now, Ohm's law tells us that in a loop, so we're looking at this loop, the total potential is given by the total current times the total resistance. Total potential for our loop is just the EMF. Total current is I. And now there are two resistors in our loop, this capital R and small r. So the total resistance is R plus small r. With some basic algebra, we can rearrange terms to solve for the unknown, which is capital R. We calculated all these quantities in the previous two parts of the problem, so we will substitute them. 3.08, current flowing is 1.65 minus 0.066. So this gives us that R, with some little algebra, will get to be 1.80 ohms. So with the help of Ohm's law, we have calculated the value of the resistance of the resistor, the internal resistance, and the EMF. Thanks for watching.